Hello guys, welcome to what could possibly be one of the longest and most frustrating videos you'd ever see. But at the end of this video, everyone who watches it will definitely be smiling. What I have prepared for you, it is what we call the function exam tricks. Guys, I know all of you can find the turning points, x-intercept, you can find all those nonsense. But what about these types of questions? These types of questions for transformation. What about these types of questions for reflections? And what about these types of questions for, these are the hard questions that I want us to do. So this is going to be a little bit of a long video. So ensure that you are listening to me extremely well. And I'll try my best to ensure that each and every single one of you guys understand whatever nonsense I would be teaching on this video. So this one is for functions. However, these things actually apply on differential calculus. So ensure that you are listening to me quite well, because this is going to be one hell of a ride. Let's actually start. Let's just start with something simple. Suppose you are given the function f at x, right? And you are being told that this function f at x actually equals to x squared. How can you graph this function? You know that if you are given f at x that equals to x squared, you are going to graph this in this manner. You're going to say, well, it is going to look something like this, right? So this is going to be the original f at x. But what happens when I say, you know what, wherever there is x, I'm just going to put x minus 1. So it means that I'm now going to have x minus 1 squared. This is what we call transformation, right? This is what we call transformation. So on transformation, we are actually shifting the graph of f at x, or we're just shifting the function, right? So when we shift this function, whenever it is x minus 1, the graph will actually shift to the right, or to the positive side. To the right or to the positive side. Whenever it is a minus, the graph will move to the right with the value that is actually been given. So for this example, we are moving minus 1 unit to the right. So the graph will just shift 1 unit to the right. So what are we going to have? So the new graph that we are going to have, this is our point 0. So now when we shift this graph, it is actually going to look something like this. So the new graph that we are now having, it is actually at point 1 and point 0. We have actually shifted 1 unit to the right. But after shifting 1 unit to the right, you realize now we are having a y-intercept. So how can you find the value of this y-intercept? But how do you find the value of any y-intercept? By what? By letting x equals to 0. So if we come to this new function, that is actually f at x minus 1 equals to x minus 1 squared. Wherever there's x, we're just going to put 0. So we're going to have 0 minus 1 squared. And we're going to have a value of 1. So it means that this point is actually 0 and 1. So this is shifting the graph 1 unit to the right. But let's say they do something interesting. Let's say they come to you and say, okay, now we are having f at x minus 1, but we are also minusing 1. So this is f at x. We did this at first. We said it is f at x, x minus 1. It is going to shift 1 unit to the right. But after shifting 1 unit to the right, we are minusing 1. So what are we going to have? It means we're going to have x minus 1 squared, and we also minus 1. Outside we minus 1, right? So it means that now you have this function, x minus 1 squared minus 1. What happens with this minus 1? Well, here's the difference. When you put a value of minus 1 on the place of x, you're going to shift the graph to the right. If this was a positive 1, the graph would have shifted 1 unit to the left. right? But when you put a -1, it doesn't mean that it's going to move upwards. It will move 1 unit downwards, right? So it is actually going to move 1 unit downwards. So it is actually going to move 1 unit downwards. So when it moves 1 unit downwards, how do you sketch it? The first sketch, this is how you interpret it. You are going to say, well, it will move 1 unit to the right, and that is what we have done. We have moved it 1 unit to the right. But after moving it 1 unit to the right, what we're going to do, we're going to move it 1 unit downwards. So if we move it 1 unit downwards, it means that each and every single value of y, we're going to -1 to it. So what are we going to have? So this is the values of x. It is 1. The values of x, they do not change at this point because we are not shifting the values of x, we are shifting the values of y. So it means that the values of x will remain to be 1, but on each values of y, we're gonna -1. So it's becomes 0 minus 1. That is actually going to become -1. Still here, the values of x is not changing, so it still remains to be 0. But we're gonna shift it 1 unit downward, so we're gonna have 1 minus 1. That comes back to 0. So it means that the new equation, it is going to look something like this. Right? We just shifted this graph downwards by 1 unit. We just shifted this graph downwards by 1 unit. So this is what we have done. Firstly, we shifted this graph to the right by 1 unit. And then we shifted the graph to the right by 1 unit. And then afterwards, we shifted the graph downwards by 1 unit. And then we shifted the graph downwards by 1 unit. That is what we call transformation. That is the concept of transformation. To a lot of people, it might be a headful. So just try not to think about it too much or overthink it. Just be flexible. You know, just how you are when you are, I don't know. Yeah, just be flexible. Let's actually look at another exciting concept. This one is called reflections. Reflections. Well, I realize we have learned about transformation ever since we were in grade 5. We used to transform some triangles and some circles back in the day. Do you remember it? And we also did reflections. I remember doing a reflection of a hexagon or octagon back in the day when I was in grade 5, 6, and 7. And I never thought that concept will interact with graphs. So how do you actually do the transformations or the reflections at this point when it comes to graphs? So there are 2 types of reflections, of course. So we are having the reflection about the x-axis. So the first one, it's a reflection about x-axis. And the second one is going to be reflection about y-axis. So we are having the reflection about the x-axis, and we are also having the reflection about the y-axis. Let's look at this first one. What is the reflection about the x-axis? What is the reflection about the x-axis? If you are given y equals to minus f at x, this is the reflection about the x-axis. Just know it. Just know it. I'm going to explain it though. When you are given the reflection about the y-axis, you're going to have y that equals to f minus x. This is the reflection about the y-axis. How do I mean by this? How do we mean by this has reflected about y and this has reflected about x? Let's say we are having a wonderful Cartesian plane, right? If we are having this wonderful Cartesian plane, let's say we are having a point A somewhere here. And this point A, it is 3, and then it is actually 4. We know this is our x-axis and we know this is our y-axis. Now let's reflect about x-axis. When we reflect about x-axis, as you can see, remember, f at x means the value of y. We know that, right? F at x means the value of y. What have we done to this point? They've actually put a minus just before the value of y, isn't it? So they've actually put a minus just before the value of y. So what do we want to do with that? What happens if we put a minus within the value of y? It means that this thing would actually look something like this. We're just going to put a minus on the value of y. When we put a minus on the value of y, this becomes minus 4. But where is minus 4? Minus 4 is going to be on the negative axis. So we're going to have a prime that actually equals to 3 and minus 4. We have reflected about the x-axis. The x-axis is the mirror. Can you see? Reflection about the x-axis. X-axis is the mirror at this point. Or maybe the line in between these 2 points is the x-axis. So therefore, this is the reflection about the x-axis. What have we done? Because we have put a minus just in front of the y value, we do the same thing with the coordinates. We just come here and put the y in front of the y value. And then this just becomes the reflection about the y-axis. About the x-axis, I meant to say. But what about if we reflect this about the x-axis? When we talk about the reflections about the x-axis, what are we talking about? Well, when you reflect something about the x-axis, you realize that we have actually put a minus just in front of the x value. So if we put a minus in front of the x value, we know that the minus sign is actually here. The a second prime, it is going to be minus 3, and then we're going to have a 4. So it's just be minus 3, and then we have a 4. So this is the reflection about the y-axis, because the line that is actually in between these 2 points is actually the y-axis. So we have reflected this point about the y-axis. So this is the concept of the reflections. This is what we mean by the reflections. I hope that you guys have actually grasped that. So let's just take a break a little bit. Yeah, life, right? I don't know, just start to think, what is the thing that is actually stressing you about school at this point? What is that teacher that you hate so much? The teacher that I used to hate at school, it was, did I even have a bad teacher? Actually, my school was great. I never had a teacher that I hated. But if I were to hate a teacher, I would hate this guy called Mr. Shidzinga. By the way, I love him so much. Mr. Shidzinga is one of the people that, you know, if it wasn't for people like him, I wouldn't be where I am today. So I don't want to tell him straight to his face. I just want to do something nice one day, and then I go back to him and be grateful. But if I were to hate a person, I'm definitely going to hate him. That guy gave me a hard time when I was still in high school. You know, because when you are having teachers that actually loves you, you know, they end up being so strict. And the reason for them to be strict is because they want you to be successful in life. So yeah, I hate him so much. That he used to make me go to school extremely early. When I do nonsense, he would drop me, you know, on the back. He would, you know, he just wanted me. I remember when I was writing my exams, even my final exams, I was at school. When I was in grade 12, I never skipped any day of school because of him. He wanted me to be at school each and every single day. Whether it's time for the final exam and we were not writing, he would want me to be at school, you know, from morning until evening. So yeah, he truly made my life a living hell. But it is because of him that you have such a wonderful teacher. He used to support me so much. I also had my extra classes when I was in high school, but it was for free. So I didn't know that I was training for this. So if it wasn't for Mr. Shidzinga, you guys wouldn't be having me teaching you right now. So you wouldn't be understanding these things of reflections and stuff. Okay, let's actually get back to this wonderful journey. I want us to do this question. Nag. It's about to go down. Okay, let's actually do this question, right? We want to do this wonderful question. We just want to do this wonderful question. Okay, so we are given f at x that equals to 8 minus x minus 2 plus 2, right? So I just want to write this down. We are actually being given a wonderful expression. The expression that we are given it is that f at x, it is going to equals to 8 x minus 2 and then a positive 2. So they say determine the equation of the graph which is formed if f at x is shifted 3 units to the right. So they say that f at x is actually shifted what? shifted 3 units to the right. If we shift the graph to the right is the positive side. It means that we're gonna put a minus. Do you remember? In front of an x, we're gonna put a minus. We put x minus 3. Remember? We're gonna put x minus 3. So it is going to shift to the right. And then reflect across the x-axis. So it actually reflects across the x-axis. Do you remember our reflection? So reflection across the x-axis, we just put a minus f at x, right? So how do we do this? Well, we are going to say, this is what, by the way, guys, this is what they are looking for. Let's just write it like this. This is what they are looking for. They say, determine the equation of the graph. So it is a new graph. Let me just call this graph y. So this graph, what happens to it? It is what shifted 3 units to the right. So when we shift 3 units to the right, we're just going to have f. Whenever there's x, we're gonna minus 3. So it can actually move 3 units to the right. Can you see? And then reflect across the x-axis. So when it reflects across the x-axis, what we do, reflecting about the x-axis, we just put a minus just in front of the y. So it means we also put a minus in here. This can be the equation if you want. This is the simplification of it, but now you need to simplify it, right? You need to simplify. This is in simple form or in explanating form or whatever. I'm not an English person. But how do you write this in here? You say, well, this equation of y, it is simply going to be 8 equals to, what happened, guys? We realize that wherever there is x, we have minus the 3. And then we're having minus 2, and then we're having plus 2. But there's something interesting. What is f at x? F at x is this equation. Can you see it? F at x is this equation. But what have we done? In front of this equation, we have put a minus. So we should also do it in here. We should put a minus in here outside. So it means that the graph becomes y equals to minus 8 divided by x minus 5, because it is minus 3 minus 2, and this minus will also affect this one. It's going to be minus 2. So this becomes your expression. This is how you were supposed to answer that question. Do you see how you were supposed to answer this question? This is how you were supposed to answer this question. One of the wonderful questions, by the way. So it is when you determine the equation of the graph formed if f at x is shifted 3 units to the right and then reflect across the x-axis. Let's actually look at this wonderful question. They're telling us to find h at x if h at x equals to minus fx minus 3. Do you see what they have done? It is minus fx minus 3. Here it is. What does this tell us, guys? I remember I made up this question because, like, when I was writing this question, I was also having the answers on my head. I was like, let me show these learners that, guys, sometimes they are not going to give you an explanation. They're just going to write this. It is the same. This simple math statement is the same as this entire sentence. So when you go into your junior exam, your trial exam, your final exam, your term 1 exam, you find something like this. This is what they actually mean. It's one of the wonderful stuff about science. Oh, it's math. Okay, so it's the same as that one. But now let's actually look at this next question. Let's look at this next question. We are having it's 3 graphs actually. We are having the quadratic expression, we are having the exponential, and we are having the exponential. But we get to learn that this is the original g, and this is actually the inverse of it. So this is g, the original, and this is actually going to be the inverse. And I was actually thinking of the UFC. Do you know this guy called Khabib the Eagle Nurmagomedov? He's one of my heroes. No, he's not my hero, but one of the people that actually got to inspire me. A humble guy. Yeah, let me not say that. Let me not curse or something. Yeah, but yeah, he's definitely up there. You should check his fights if you are a professional mixed martial arts fan just like myself. I love MMA, I love wrestling. Those are the two things that keeps me alive. Otherwise, I would just die. Okay, let's look at this. They are saying that for which values of x is the inverse greater than or equals to -8. So let's just focus on the inverse. Inverse is the blue one. If you are colorblind, I'm sorry. So this point, ladies and gentlemen, this point, it is actually 4 and -8. So they are asking for which values of x is g at x greater than -8. Where on the graph, in terms of x, however, when looking at the y value, is this function -8? But I want to ask you a question. What is g at x or g inverse of x? We know that g at x represents the y value. If we have g minus of x, this just represents the y-intercepts or the y values or whatever you want to say. So it means that looking at the y-intercepts, where is this thing greater than -8? If this is -8, you realize that greater than -8 is from -8. Where is it from actually? You realize that greater than -8. Okay, I want to ask you guys a wonderful question, and I want us to be fair about this thing. Let's say, for argument's sake, I draw a number pattern. This is 0, this is 1, this is 2, and this is 3. This is number 1, yeah, -1, -2, and then this is -3. We can actually say that when we move from the left to the right, the numbers are increasing, isn't it? The numbers are increasing, or the numbers are becoming large. However, if we move to the right to the left, the numbers are becoming smaller. What does this tell us? This tells us that 1 is greater than -1. I mean, like in logic. If you have 1 rand, you have a lot of money instead of when you are in a debt of 1 rand, right? So if you have 1 rand, you are having money than in a debt of 1 rand on 1 rands. So this tells us that numbers from the negative become smaller, right? They become less. When we move to the negative, we are having less. But when we move from the negative to the positive, we are having greater. So it means that for you guys not to be confused, when they say greater than -8, don't count to this side because it is not becoming greater on my understanding, but I stand to be corrected. I feel like we are not becoming greater, but the numbers are becoming smaller, according to the number pattern. But when we move from -8 until to the positive side, the number becomes larger, isn't it? So they are asking us, for which values of x is this negative inverse is greater than -8? You realize that from x equals to 4, until 0, this condition is met. When x equals to 4, we are having -8. It is greater than -8. When x equals to -3, we are going to have some point which is going to be greater than -8. When x equals to 1, we're going to have 0, whatever, until this point actually equals to 0. So someone would say, but Marvel, when x equals to this point somewhere here, we are having something like this. Yes, but until we reach 0, can you see? As long as we're from 4 to 0 or from 0 to 4, this condition is met. So our answer, we're going to say our answer, it is XE from 0 until 4. And we're going to include this 4. If you did not understand this, just text me after. I'll try to explain, but this is the best way I could have explained this. Okay, they ask us, where on this graph is x multiplied by f at x less than 0? For those of you who attended the live session, let's look at something. I've asked people this. If you are having positive and you multiply it by a negative, you get a negative. If you have a negative, you multiply it with a positive, you get a negative. If you have a positive and multiply it with a positive, you get a positive. If you have a negative, you multiply it with a negative, you get a positive. So they are actually looking for a minus, because less than 0 means a minus. So we are going to say we want to check when x is minus and when f at x is positive, because this will give us a minus answer. And we want to check when x is positive and when f at x is negative, because it is actually going to give us a minus answer. Do you understand what I'm saying? Now, let's look at on the graph where x is minus. Let's start with this first condition, where x is minus. So x is minus from 0 until to this side. So from 0 until to this side, x is minus. By the way, we're looking at f at x. This is f at x, right? And then is where on this graph, remember f at x, it is the value of y. F at x is the value of y. Now they actually ask us, where on this graph is x minus? So x is minus at this point. Within the negative side. Don't come and look at the positive side. We are concentrating on the negative side where x is negative. Where is it f at x positive? We realize that, okay, f at x is going to be positive from 3 upwards. Can you see it? Can you see it? Look, the values of x are negative. And then this value of y from minus 3, this is minus 3, until to this point, the values of y are positive. So this statement is correct. From minus 3, the x is negative and the y is positive. So it means that the answer becomes xe from what? Negative infinity until minus 3. This statement is being met. Because when we multiply minus 3, let's say we're having minus 4 somewhere in here. We're having minus 4. This is minus 4. And then you find that it is minus 4 and positive 3. When you multiply minus 4 and 3, you get a negative answer. You're going to get minus 12. And this is what we're saying, that when we multiply a negative value of x with a positive value of y, we're going to get a negative. So this statement will exist from minus 3 until negative infinity. X is negative and y is a positive. So this becomes our first answer. What about our second answer? We want to check where x is positive. So x is positive from 0 until. But when x is positive, we want to check where f at x is minus. It is this point. Can you see it? It is this point. F at x is minus. The value of y, in terms of y, the value of y of this part is minus at this point because it is minus from here. So you realize that our second answer is going to be xe from when x equals to 0 until x equals to 1. This point is 1. We are going to meet this statement. From x equals to 0 until 1, we are going to meet this statement. X is positive from 0 to 1. And then the value of y at this point is a negative. So that's how you actually answer this question. Guys, these questions requires you to do a lot of practice. Practice, Mshan. Practice. It doesn't want you to just look at the question paper and what I'm teaching you and go to sleep. You need to practice, right? It requires you to do a lot of practice. You're going to understand it, guys. Do not worry. I got you. Do not worry, I got you. And if you can understand this part of functions, you are definitely going to get 100% on functions. I'm not lying to you. Because like you know how to find the x-intercept. You know how to find the y-intercept. You know how to find the blah, 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 blah. You know it. But what you do not know is these parts. So yeah, it's still going to be a long video. So I want you to stand up. By the way, I know you did not stand up. Some of you guys are rolling your eyes. No, just stand up, dude. You're still sitting down. Dude, just stand up. Okay, I'm not going to move forward if you're not going to stand up. I'm just kidding. Okay, I just want you guys to refresh a little bit. So just go outside. If you have a sister, just slap her in the face and then just go back to your room. And then let's actually continue with this part and figure out how we're actually going to, you know, loophole this entire question. So it's going to be a little bit of a long session again. Okay, let's just look at it. I'm just taking a paper to answer on. So actually having this wonderful graph. So actually having this graph oh, is it named? Yeah, it is f at x, right? And then we're having this straight line. That is actually g at x. Can you see it? If you did not say yes, I'm gonna slap you in your face. Boom, boom, boom. I want you guys to relax. I know that most of you guys are tired. I don't know. When you're watching movies, you are not tired. When you're going to, let me not spoil. I'm gonna spoil it to your mother, so she'd know where you have been. I'm going to study at my friend's house. Study at home. If your mother is listening to this, mother, do not allow her to go and study on a friend's place. She needs to study at home. That is why these people are always studying. Don't you notice? They are always studying, but they don't pass. Where were you? Okay, let's actually look at this question. They say f at x is being given by this equation, and g at x is given by this equation. Now they say the graph of h at x, it is going to equals to x plus p plus q. So this is what we have done on the previous videos, but at this point they just represented it in terms of alphabets. So h at x is a new function, x plus p and then plus q, and they're telling us that it has a maximum value of 15. Okay, there's something interesting at this point. Oh my god. Okay, let's look at maximum values. Maximum value. Whenever you hear this term maximum value, just think of turning points. Just think of turning points. Now, where are these maximum values actually coming from? Let's say you are having a function f at x equals to perhaps x squared plus 2x, I don't know, plus 5 or something, plus 10. You realize that your value of a is going to be greater than 0. So when you are having a function that has a value of a greater than 0, okay, for the sake of saying I said maximum value, let's just put a minus. So it means that your value of a, it is going to be less than a 0 because it's a minus. So you know that when you draw the sketch of your function, it is going to be concave down. So it is going to look something like this. Right? So when it looks something like this, you realize that the top of the function, this term doesn't exist, by the way. I'm just making you understand. I can just say top of functions or something. It is actually on a maximum point. This is the maximum point. This is as far as you can go. You cannot go much further than this, right? You cannot go any much more than this. Let's say this point is 15 for argument's sake. This becomes your maximum value. So this 15 is actually touching the turning point. But which value of the turning point? The y turning point. It becomes your y turning point. This 15 becomes your maximum point. But when we talk about minimum points, when we discuss stuff about the minimum point, it is also referring to turning points. Within the sections of turning points, you realize that you are going to have a function f at x equals to x squared plus 2x plus 10, something like that. You realize that you're going to have something like this. So the value of y of the turning point is at a minimum. Can you see? This is at maximum, this is actually at a minimum. Let's say this is going to be minus 15. So because the value of a is positive, it has to be concave up. So the minimum value is actually at the curve of this function. So it becomes minus 15 as your minimum value. So this is where these terms minimum values and maximum values coming from. So this is again the y turning point, or the y value of the turning point. So when we come back to the problem at hand, you realize that they are saying that the graph h at x, so we are having the graph h at x that equals to fx plus p plus q has a maximum value of 15. So this maximum value, immediately know that it is the what? The y turning point. So the y turning point is some value x and 15. And they say has a maximum value of 15 at x equals to 2, right? So we know that it is going to be at x equals to 2. So this actually tells us that, well, the x coordinates of the turning point is 2. How do they mean by this? Look, let's say this value of x here, it's minus 4. So this one, it has a minimum value of minus 15 at x equals to minus 4. So this one, it has a maximum value of 15 at x equals to minus 4 as well. So this is how we can actually interpret it. And they say find P and Q. So they want us to find P and Q, right? How can we find P and Q? Let's just repeat this question. They said the graph of h at x, fx plus y has m. So this one, it is actually what? Shifted. Can you see it? This graph has been shifted. So let's just look at these turning points that we have. So the original turning points that we have, let me just say original TP, it is going to be 1 and 18. But what happened? We moved from the turning point of 1 and 18 to, this is the shifted turning points. So the shifted turning points, it becomes 2 and 15. How did we move from 1 to 2? So the best way to move from 1 to 2, it means you add 1, isn't it? You plus 1. You plus 1. And then how do you move from 18 to 15? You subtract a value of 3. So when you move 1 unit to the right, when you say plus 1, because you are adding 1, right? Because like in normality, it means that this turning point, it is 2 and 15. If this is 1, we can actually say that 2, it is somewhere here, and then 15 is below, it is somewhere here. Can you understand it? It is going to be somewhere here. It means that this graph has shifted 1 unit to the right. Can you see it? It has shifted 1 unit to the right. Let's just write it, just plus 1. So we can say that, well, this graph has shifted 1 unit to the right. But how do we write it when we shift something 1 unit to the right? I want to go back. You remember that this function was shifted 3 units to the right. So you realize that when we're shifting something to the right, we are going to have a minus. So now we know that within this value of h at x, f at x, where there is p, we're not just going to put a positive 1. It has to be a minus 1 in order for it to be shifted 1 unit to the right. But what have we done again? We subtracted 3. So it means that we have also what? Shifted 3 units downwards. And it does make sense if you want to look at it. I mean, even this turning point in here, you can see it has shifted a little bit down, right? So it means that when we shift downwards, we're going to say it's minus 3. So just by looking at it, you can see that where there is p, there's minus 1. So the value of p becomes minus 1. And where there is q, there's minus 3. So you can see that the value of q becomes a minus 3. So that was how you were supposed to solve this question. Now, let's actually look at this question. This question says, if p at x, it is going to equals to f at x plus k. So they say if p at x is going to equals to f at x plus k. Find the values of k for which p and g will not intersect. Okay. They're telling that we are having a new function p at x, and it is going to equals to f at x plus k. Now they say find the values of k, these values of k, for which p and g will not intersect. Let's just look at p and g. This is the graph of f, and this is the graph of g. We want this graph to not intersect. So remember from analytical geometry, it's either we intersect, we touch, or we not touch. So let me just say something like this. If in a way I can shift this graph, let me just draw it on a new paper. This graph, let me just say we're having these wonderful graphs, right? So it is something like this. It is going to be something like this, and then we are also going to have some sort of a straight line, which is going to be something like this. So this is f and this is g. We want them to not intersect. Well, if I can actually shift this graph of f downwards, when I shift it downwards, it would be somewhere here. It is not accurate drawing. If I can just come and make it to be somewhere here, I shift it downwards. You realize that the new f, I can just call it f prime, it is no longer intersecting with g. However, it has touch. And then if I can even make it to go a little bit lower, it will not touch. So it means that in a way, we need to find the coordinates of this point. We need to find the coordinates of this point. How can we best find the coordinate of this point? How can we actually find the coordinates of this point? Well, we know that the graph of g at x, it is given by 2x plus 4. So from this information, we can outsource that the gradient, it is going to be 2. So it means that this line is having a gradient of 2. What comes into your mind when we talk about gradients? Well, we know that the equation of this function, it is actually f at x that equals to minus 2x squared plus 4x plus 16. If we can say we derived this for the first time, we're going to have minus 4x plus 4. But this means gradient. It means that we are looking for the values of x where the gradient is going to equals to 2. We're just going to put 2 here. So it's going to be minus 4x plus 4. So if we take this one to the other side, we're going to have 2 minus 4. That becomes minus 2. And we're going to have minus 4x. So if we divide both sides by minus 4, we find that the value of x is going to be 1 over 2. So we now know that the x value of this point, it is actually 1 over 2. So if we can go to the function of a straight line, we know it is 2x plus 4. We can find this value over here of y. So we're going to say, well, if I substitute 1 over 2 plus 4, what value do I get? You realize that you're going to have 2 multiplied by half plus 4, you get 5. It means that at this point, somewhere here, it is going to be 1 over 2 and 5. Now, let's go back to this question. This question says we need to find the values of k. If you realize, let me write p at x. You realize that, well, your p at x, it is simply going to be f at x. What is f at x? F at x is minus 2x squared plus 4x plus 6. But we are actually now having a constant of k. Within this constant of k, we want to find this value. So this value of k, it is the unit that we have shifted off. This value of k, it is going to be 18 minus 5. This value of k should be 18 minus 5. It is going to be 18 minus 5. So what is 18 minus 5? If you think of it, what is 18 minus 5? So 18 minus 5 actually equals to the value 13. It means that the distance between these 2 points, it is actually 13 units. So on another word, in order for P and G to not intersect or not touch, the graph of f at x needs to be shifted downwards by 13 units. So it means that this value of k is going to be, I shouldn't say equal, it should be greater than or equals to minus 13, not a positive 13. It should be k equals to greater than or minus positive 13. So if we shift this graph 13 units downwards, it is not going to intersect. However, it will touch or not touch. So the new function of p at x, it becomes minus 2x squared plus 4x plus 16 minus 13. So 16 minus 13, it becomes 3. So this is your equation of p at x. And this is how you were supposed to find it. Well, I feel like that has been a lot of information and we still have got a long way to go. So the best thing to do at this video is to just pause it over here. So you're just going to find these following values. try to answer these questions on your own and then see what you are going to get. And at the very same time, you are also going to find these questions and see what you are going to get, and also do this one and see what you are going to find.